Geometry 1.3 notes. It's on segment lengths. So here's our first example. You have a number line here, and it says, what is AB? In geometry, you need to read this as what is the distance from A to B. So yeah, read as the distance from what is the length from A to B. So you can do this a few different ways. You can just count from A to B. There are 1, 2, 3, 4. So the distance is 4. But in case you are wondering about the other ways, let's go ahead and look at the next example. What is the distance from B to D? Okay, you can either count them from B to D, and that's totally fine. But if you don't have a number line, if you don't have it like this, it just says maybe where B is at and where's D, you can find the difference between the two. And if you remember in math that the difference means subtract, then we can put -3 minus 4 because that's the difference between the two. So -3 minus 4. And what you need to know about distance in whenever you're measuring lengths is it's the absolute value. It's not going to be a negative amount. If I tell you how far is this distance, it's not going to be a negative distance. It's just a distance. Doesn't matter if you go from start to finish or finish to start. Like, doesn't matter the direction you go. So for that reason, it's the absolute value. So -3 minus 4 is -7, but the absolute value of -7 is just 7. Just in that same way, you could have reversed it. We could have said, what's the difference between 4 and -3? So 4 minus -3, because it's a distance, you're taking the absolute value. That would be 4 minus minus becomes plus plus, which is +7. And the absolute value of 7 is 7. And once again, you could have just come up here and counted 1, 2, 3, 4, 5, 6, 7. So the distance is 7, no matter which way you choose to do it. Okay, so let's look now at the length of AB. So from A to B, it's the absolute value of subtracting the 2. So let's take a look now at what is the distance of BC. Let's look below. There you go. What is the distance from B to C? So the distance from B to C is here. What is the distance from C to E? That would be on the next one. So here's what we need to know. If the distance from A to B equals the distance from B to C, then here's what I want you to start understanding. This word is congruent. This symbol, which is just an equal sign with kind of a little tilde, if you guys are in Spanish, one of these little lines, this means congruent. And congruent means exact. It means equal, and it's usually talking about the size of a shape or the distance of a length in geometry. So AB is congruent to BC if the two lengths are equal. So if the two lengths are equal, they are congruent to each other. Okay, we didn't really talk about this yet, but let's go ahead and go to the next page. It says if the coordinates of K, L, M, and N are -12, -4, 0, and 4 respectively, let's graph those points. So first we're going to draw them on a number line. I think that if you see them on a number line, they're a little bit easier to be able to find distances of. So we need to go all the way from -12 to +4. So the distance between those would be 16, so 8. I'm just kind of talking out loud right now. 4, just to try to see how many I need in between. It's okay if you don't space them out perfectly. It will be all right. I hope I did that right. Let's double check. So here's -12 on the number line. -11, 10, 9, 8, 7, 6, 5. -4 is right here. 3, 2, 1, 0 is right here. And then 1, 2, 3, 4 is right here. Okay, so graph those points on a number line. And then let's find the following. Oh, K, L, M, and N are what they are. So K, L, M, N. All right, so let's find the following. The distance from K to L. So on a number line, you can just count it. So K to L is however many that is, Or you can do negative 12 minus negative 4. Negative 12 plus 4 would be negative 8. And the absolute value of negative 8 is positive 8. So again, you could have just counted, and that's fine too. So 8. Let's go ahead and look at Km. Km, let's say this is 8, so that would be 9, 10, 11, 12. And that was a very lazy way to do it. I definitely want you to practice understanding how you're subtracting to find distance, the difference. K to N, let's go ahead and do that. That's negative 12 to positive 4. So negative 12 minus, this is positive 4. If you do that, what's inside the absolute value bars, negative 12 minus 4 is negative 16. But since it's absolute value, the distance is positive 16 because distances are always positive. Okay, the next one says LM. So this one's going to be easier, I think, just to count. So it's 1, 2, 3, 4. Again, you could have subtracted, used the absolute value, lots of different ways. LN, if we know this one was 4, this is 4 more, so that is a total of 8. I'm getting lazy, I'm sorry, I'll work out the next one, I promise. MN, the distance from M to N. Oh, okay. Well, 0 and 4. I told you I'd work it out. Let's do it. 0 minus 4. 0 minus 4 is negative 4, and the absolute value of negative 4 is positive 4. Okay, which of these segments are congruent? So let's look. We have 8, 4, 12, 8, 16, and 4. So there are a couple of them that are congruent. That would be MN because it's 4, and LM because it's also 4. So let's write some congruence statements. So if LM equals MN, then our congruent statement would be LM is congruent to MN. Okay, I think there's one more, and this is really all you need. This is the congruent statement. The other one I noticed was that KL was equal to 8, and LN was also equal to 8. So let's write a congruent statement for those. KL is congruent to LN. Okay. All right, let's look at your last page. This is the segment addition and segment subtraction postulates. Postulate is a fancy way for saying a rule in geometry. So a rule. Okay, so this is very self-explanatory, but I want to point out what it's saying. It says from A to B, so this distance from AB, the distance of AB, plus the distance BC equals the entire distance, A to C. And that's really all segment addition is. It's like taking a part of a segment and adding it to another part of a segment to get the entire total length of the segment. So the same thing works when you're subtracting, obviously. You would take the whole thing and subtract out one part of a segment to get the other, or you could take out the whole segment and subtract out the other part to get the other remaining one. So let's try it out and see if you guys can figure this out. If KR equals 13, so from here to here is 13. And from R to S is 8. What distance is it from K to S? Okay, this is not tough. So obviously it would just be 13 plus 8. Segment addition, we're adding two segments together, and that would make it 21. So the distance of KS equals 21. Okay, let's try the next one. TL, LP, TP. So this time we're doing a little algebra. I know you guys are all excited about that, so let's do some algebra here. TL is x plus 4. So from here to here, we don't know the distance, but we know that it's x plus 4 would represent it. Okay? From L to P, we also don't know this distance, but we know that 3x plus 5 would represent it. And we don't know the whole distance, but we know that the whole distance can be represented by 8x minus 3. Okay, it wants us to go ahead and solve for x, solve for the length of TL, solve for the length of LP, solve for the length of the whole T to P. So let's try this. I hope you know that we're just doing it the exact same way we did it up here. This plus this equals the total. So x plus 4, I think I gave you a little room over here. X plus 4 plus 3x plus 5 would equal the whole thing, which was 8x minus 3. All right, let's do some algebra. X plus 3x is 4x. 4 plus 5 is 9, positive 9. Okay, let's just bring the other side down. You have to move one of the variables to the other side, so we're going to subtract 4x. Again, you don't have to do it this way. There's 4 different ways you could do it at this point, and you would get the same answer. I chose to subtract the 4x. Bring down your subtracted 4x and your minus 3. We're going to add 3 to both sides. Just working this out to help you jog your algebraic memory here. So 12, and then I'm running out of room, but I know you guys know the last step would be divide by 4, and x equals 3. Okay, so what is x? X equals 3. What is the length of TL? So let's go back over here and look at TL. If we know that x equals 3, then the length of TL would be 3 plus 4, so 7. All right, LP. If you know that LP was 3 times your x plus 5, and we know that x is 3, then we've got 3 times 3, which is 9, plus 5, which is 14. And then lastly, the whole distance. You could actually go plug in your 3 here and solve it out, or now that we know that TL is 7, LP is 14, you can just add those together to get 21 for the entire distance. And again, if you would plug that in, I think you would also, well, you should also get 21 as well. Okay. I would really like for you guys to try this last one on your own, but before you push pause and try it on your own, I need to tell you that these little double hash marks means that from M to R is the same distance as from R to S. It's almost like they are equal sideways. So they're little double hash marks, and they mean they're equal to each other. So now that you know what those little lines mean on each of these 2 segments, push pause and see if you can figure out this, and then I will work it out with you. So fast forward to see if you did it right. And if you did, awesome. And if you did not, watch me work it out with you so that I can figure out, so you can figure out where you went wrong. Okay, what it says over here is why these little hash mark things are here, and that is that MR, from M to R, it's congruent to RS, which is the other side. So these just mean they equal each other. Okay, so if we know that MR equals 4x minus 3, and we know that RS equals 2x plus 7, it doesn't really matter because these 2 equal each other. So since they are the same and they equal each other, I would set up an equation with these 2 equal to each other. So I'm going to try to find some space. I'll just go to the bottom of this other paper here. So I would write 4x minus 3 equals 2x plus 7, and I would solve that with algebra. So I'm going to minus the 2x from both sides first. Again, that's not your only way to do it. Bring down your minus 3 and your 7. Add 3 to both sides. 2x equals 10, which means x equals 5. Okay, so since x equals 5, it wants to know what x is. So that's 5. It wants to know what MR is, so let's go plug in 5 for x and see. 4 times 5 is 20, minus 3 is 17. So MR is 17. We don't have to do the math on RS because if RS is congruent to MR, then that means they are both 17. And the entire distance from M to S is 17 plus 17, which is 34.